Okay. So our next experiment is determination of diode ideality constant. Okay, so we have this diode equation or Shockley equation, which deals with the current flowing through the diode as I equal to I naught
E power QV Q eta KT -1.
minus 1. So this is the diode equation or Shockley equation. Okay, so here eta is the ideality constant, which we need to determine for the given diode. And here V is the voltage applied. V or Vd is the diode voltage. So now we need to fetch this value of eta, and what are the variables? Here t can be a variable. So to measure the band gap, we have varied the temperature. So that we have seen already, and that too it was in reverse bias. So that equation becomes e power minus qvd by eta kt. That was the equation we have used to determine the band gap of the diode. Now our aim is to fetch this ideality constant. Okay, so Vd is the diode voltage, T is the temperature, K is Boltzmann constant, Q is charge of electron. I naught is a material constant, I is the current. Okay, somehow we have to fetch that value of eta, and we have two variables, temperature and diode voltage. So in this case we are taking diode voltage as a control parameter or the user dependent variable, and t is assumed to be a constant. So I am varying Vd, and I would like to see how current varies, and from that data I would like to fetch the value of eta. Okay, so I am considering positive voltage, that means forward bias. When the diode is forward biased, with the rise in voltage, current also increases. And here I am taking an assumption that voltage is sufficiently high that exponential of this entire term is very large compared to 1, so that I can neglect that 1. So Vd is sufficiently large so that e power qvd by eta kt is very greater than 1. So then I is equal to I naught e power qvd by eta kt. So I'm taking that assumption just to ensure I have exponentials and multiplications. I mean, I try to avoid that subtraction part. So that if I take logarithm on both sides, what do I get? So log I is equal to log I naught plus qvd by eta kt. So here Vd is the independent variable, I is the dependent variable. So I have to draw a graph between Vd and I. So this looks like a straight line y equal to mx plus c with positive slope. So this is the log I naught, and slope is what? So I have to take log I. Slope is what? Slope is equal to q by eta kt. So in other words, ideality constant eta is equal to slope times kt by q. So here k is Boltzmann constant. What is its value? T is temperature in kelvins. Q is charge of electron. Boltzmann constant.
1.380. 649 into 10 to the power of minus 23 meter square kg second. Meter square.
Joules per Kelvin. 10 power minus 23. So Q and K. So what do you get? KT by Q value. 1.38 into 10 power minus 23 into 300 by 1.6 into 10 power minus 19. This is minus 21 minus 19 minus 2 4 by so 0.02. Confirm that value. So this eta value is whatever slope you get multiplied by 0.02. And since this is forward bias, you have to consider these numbers in milliamperes. I is in milliamperes. Vd is in volts. So during forward bias, forward voltage is in volts, current is in milliamperes. So these units are necessary while calculating that slope. Okay. So you have to take That's a 1N4007 diode, and you have to forward bias it. You have to vary the voltage, maybe use a voltage generator here, and an ammeter. So DC voltage, so if you vary, so you have to vary the voltage and measure the current. VD I log I. So these are the things you need to tablet, change the value of voltage and get the current. Finally, you have to plot a graph and make a linear fit to that data, and you need to get the slope.